Welcome back, students. In today's video, we are going to learn a very interesting topic in mathematics. See on the screen. We have a number pattern 3, 5, 7, 9. Can you guess what number will come next? Yes, correct. 11. Why it is 11? How you got it? Because each time we are adding 2 in it. So that's why it will come 11. After that, it will come 13. So whenever numbers follow a fixed rule like this, we call it a sequence, because here we are adding every time 2 in it, right? So when the difference between consecutive number is always the same, consecutive number means what? After the number, whatever the number is, if you subtract the previous number from it, then the difference will come same all the time. So this type of sequence is called arithmetic progression, or simply we call it in short AP. So this pattern will become 3, 5, 7, 9, 11 is an example of arithmetic progressions. Now, next thing is common difference. Look at another pattern 5, 8, 11, 14, 17. Here, observe the change between the numbers. 5 to 8 means what we are doing here, plus 3. 8 to 11 plus 3, 11 to 14 plus 3. The same number is added every time. So the constant difference is called the common difference. We represent common difference by the letter D, students. So in this sequence, the common difference will become 3. Okay, because every time we are adding 3. Or you can find it in this way also, term 2 minus term 1 or term 3 minus term 2, all will give you the same common difference. Okay, now an arithmetic progression we are seeing where it is decreasing order. For example, 8, 5, 2, minus 1. So here the number are decreasing by 3 in each time, right? So the common difference will become minus 3. So the most important property of an AP is that the difference between the consecutive terms remains constant. Okay, D has to be constant throughout the AP. In AP it can't be in first 5 term it will be some other difference, and in other 5 it will be some other. It can't be like that. In the whole from A to Z AP, in the entire AP, the common difference has to be same. This is the most important property of the AP. Next is finding the nth term. Consider this sequence 3, 7, 11, 15, 19. Here the first term is what? 3, and the common difference is 4. If we want to find the next few terms, we can keep on adding 4. But what if someone will ask you to find the 100th term? So what you will do? Writing all the term one by one would take a lot of time, right? Mathematics gives us a shortcut for this. You can also think in this way. The first one is A, right? Second term, how you are finding? With A plus D. Third term with A plus 2D. That means in every time when you are going to next term, you are adding one more D in that. Okay. So in the first term, we don't have any D. In the second term, we have one D. In the next term, we have, means in third, we have 2D. In fourth term, we have 3D. In fifth term, we have 4D. So in the last term, we will have how many Ds? Whatever the total term will be, minus 1D, means n minus 1D, right? So in this way, we can make one formula from here, which is an is equal to a plus n minus 1D. Understood? So a is the first term, d is the common difference, and n is the number of terms altogether. Now, one real life example of AP. So AP does not appear only in numbers, students. We use it in our day-to-day life also. In row wise, when we see any stadium, there also they use this concept to make the people sit in a sequence wise, where they increase in the form of AP. So many real life patterns from AP, such as steps of a staircase, rows of seats in a stadium, stacked coins or blocks, regularly increasing measurements. So arithmetic progression helps us understand these patterns mathematically. Next, the last one is sum of an AP. Now consider this problem. Find the sum of the number from 1 to 100. How you will add it? Adding all the numbers one by one would take time, right? And this is not a clever method as well. So clever method to solve this question fast is pair the number from the beginning and the end. For example, 1 plus 100, 2 plus 98, 3 plus 97, all this will make 101, right? Because 1 plus 100 will be 101, 2 plus 99 will be 101. So like this you can add all this number. So how many pairs will come? 50 pairs. So the total sum becomes 50 into 101, that is 5050. Now here, student, the ideas of this formula for the sum of an AP will become first term plus the last term into total number of terms. 100 is there, so 100 by 2, that is 50. Correct? So 50 into first term plus last term. So that's why our sum formula will become n by 2 into a plus l. And in place of l, you can write a plus n minus 1d. Okay, so it will become n by 2 2a plus n minus 1d. So today we understood 5 important ideas about AP: pattern recognition, common difference, nth term formula, real life AP patterns, and then sum of an AP. So in the next step, you can let me know in the comment section what you want to see the next. Thank you, students. Bye.